All right, in section 3.3, we're going into more stuff with the parallel lines. We're still going to use those special angle pairs. This time we're going to learn how can we prove lines are parallel using angles. So corresponding angles converse says that if two lines are cut by a transversal and the corresponding angles are congruent, then the lines are parallel. So we have an example here. They tell us that find the value of x, and we're going to use the corresponding angles converse. We're going to find the value of x that will make the lines parallel. So to make the lines parallel, so if the lines are parallel, you know that these two angles, because they're corresponding, would have to be congruent. So we would say that 2x plus 3 would have to equal 71 in order for those lines to be parallel. Because again, to be parallel, the corresponding angles have to be congruent. So we have to cancel out a plus 3, you minus 3. So 2 times x equals 68. We divide by 2 to get x equals 34. So for those lines to be parallel, x would have to be 34. All right, checkpoint 2 is the same thing. What value of x would make the lines parallel? Well, these are corresponding angles. So for the lines to be parallel, the corresponding angles would have to be equal or congruent. So 5x minus 7 would have to equal 98 for these to be parallel. So cancel out a minus 7 by adding 7. So negative 7 plus 7 cancels. 5x equals 105. 5 times x, how do you cancel out a times 5? Divide by 5. So x equals 21. So if x is 21, then the lines are parallel. So again, we're trying to find out how can we know if the lines are parallel. If the corresponding angles are equal, then they're parallel. Theorem 3.4 and 3.5. 3.4 says that if two lines are cut by transversal and the alternate interior angles are congruent, then the lines are parallel. Likewise, if two lines are cut by transversal and the alternate exterior angles are congruent, then the lines are parallel. So basically, the alternate exterior angles are congruent makes them parallel, and if the alternate interior angles are congruent, then the lines are parallel. And I believe our last theorem says that if the two lines are cut by transversal and the consecutive interior angles or the same side interior angles are supplementary, then the lines are parallel. So example 2 is a real world problem. It says, how can you tell whether the sides of the flag of Nepal are parallel? Well, if these lines are parallel, what do you know about these special angles? Well, in order for those lines to be parallel, those angles are alternate interior angles. So in order to be parallel, we'd say, well, the alternate interior angles are congruent, therefore the lines are parallel. And that's theorem 3.4. If the alternate interior angles are congruent, then the lines are parallel. So on the checkpoint, if measure of angle 1 plus measure of angle 2 is equal to 180, can you prove the lines are parallel? Explain. So we would say, well, angle 1 and angle 2 are same side interior angles, and they are supplementary. Therefore, line A is parallel to line B. So same side interior angles are supplementary means the lines are parallel. Right, in example 3, it says in the figure A is parallel to B. So A is parallel to B, and angle 1 is congruent to angle 3. Prove X is parallel to Y. So basically, we have like a mini proof here. So we know that A is parallel to B. So since A is parallel to B, we could say, if you ignore the bottom part, what kind of angles are 1 and 2? Well, 1 and 2 are corresponding. So we could say, well, angle 1 is congruent to angle 2 because parallel lines implies corresponding angles congruent. So we could say 1 is congruent to 2 because they're corresponding angles and the lines are parallel. Okay, so if 1 is congruent to 2, okay, and 1 is congruent to 3, now we can say, well, angle 2 is congruent to angle 3 by transitive property. So basically, 1 is congruent to 3, and 1 is congruent to 2, so we can say, well, 2 must be congruent to 3. Because if 1 is 10, then 3 is 10, and if 1 is 10, then 2 is 10. So therefore, all 3 of them have to be the same. And then lastly, so now if you look at just this part here, oops, I want that, here, here, and here, you can see angle 2 and angle 3 are alternate exterior angles. So you'd say alternate exterior angles congruent implies lines parallel. So therefore, X is parallel to Y, because X and Y are the two highlighted lines. Okay, so essentially we just proved that since the alternate exterior angles are congruent, therefore the lines are parallel. And the checkpoint is another like mini proof. We're going to skip this. I'm not going to go through that. That's not a huge deal. And theorem 3.7 says that if two lines are parallel to the same line, then they are parallel to each other. It is the transitive property. So, like in the picture, if P is parallel to Q and Q is parallel to R, then they all are parallel. So example 4 says each utility pole shown is parallel to the pole immediately to its right. Explain why the leftmost pole is parallel to the rightmost pole. So basically, this pole is parallel to the pole to its right. Then pole 2 is parallel to pole 3 because it's to its right. Pole 3 is parallel to 4. 4 is parallel to 5, and 5 is parallel to 6. So we know that they're all parallel to each other. Because it's transitive property. That's our reason. Transitive property. If 1 is parallel to 2 and 2 is parallel to 3, 3 is parallel to 4, 4 parallel to 5, they're all parallel to each other. So that'd be the transitive property. All right, and checkpoint 4, we're also going to skip because it really is the same thing we just talked about. How do you know that each slate is parallel? Well, if they're all parallel to the one before them, then they're all parallel to each other. It's just like example 4 that we just did. All right, so that was just a little addition onto what we already know about parallel lines and special angle pairs.